Good morning, everyone. So today we are going to discuss about vibrations and acceleration measurement by using seismic displacement sensing accelerometer or linear seismic displacement sensing accelerometer, or we call it as a potentiometric accelerometer. So here we are measuring vibrations and accelerations, vibrations of the motor or vibrations of the given engine or vibrations of the any machine, so or vibrations of the motor. So we'll finding these vibrations by using this type of seismic displacement sensing accelerometer. So now we'll see the working, construction, advantages and limitations of this seismic displacement accelerometer. So here first we are going to discuss about the basic principle. So the principle here, so now we'll see the basic principle. Basic principle is, so when the spring and mass, so here now we'll see the construction of this linear seismic displacement sensing accelerometer. So it consists of spring, sensing mass and damper, so that will be fixed in this housing frame. So here we have a rectangular, so this is we have a housing frame. So in this we have a spring, sensing mass and damper will be connected here. So now we are going to see the principle. When the spring and mass and damper is subjected to acceleration, so whenever the given machine is given engine will be vibrating, so this instrument, this accelerometer will be connected to the this machine. So when the spring and mass is subjected to acceleration and vibrations, so here the mass will be displaced. The mass will be displaced. So the displacement of the mass is proportional to the acceleration of the given motor or engine. So this is the basic principle. So when the spring, mass, damper will be subjected to the accelerations or vibrations, so here the mass will be displaced. The mass will be displaced. So the displacement of the mass is proportional to the acceleration of the motor or acceleration of the engine or vibrations of the engine. So this is the basic principle. This is the basic principle. So now we'll see the description and working of the seismic displacement accelerometer. So first we'll see the description. So it consists of spring mass, damper and spring. This entire instrument will be connected to the machine or engine or a motor. So here we are finding vibrations of the motor or vibrations of the engine or vibrations of the any machine to like a lathe machine or drilling machine, like that. So that this instrument will be connected to the particular machine for measuring the vibrations, So here it consists of the spring, and at the top portion we have a damper. So then we have a spring mass. So this sensing mass will be displaced here. Then we have a damper. This is about damper. So damper will give the support to the mass. Damper will be giving the support to the mass. So it will be avoiding the unnecessary, if any unnecessary vibrations are there, so it will be avoiding this by using the damper. So it give cushioning effect to the sensing mass. If any unnecessary vibrations are there, so that will be the unnecessary vibrations. So the unnecessary vibrations will be avoided by using this damper. So it will be giving the support to the sensing mass and avoiding the unnecessary vibrations by using this damper. So here the sensing mass will be connected to the spring and where the machine is to be connected, and then damper also in between the sensing mass and housing frame. So these are the important components, important parts of this seismic displacement sensing accelerometer. So these displacement will be finding by using the electrical displacement transducer. So this is the electrical displacement transducer. This is about electrical displacement transducer. So this, whatever the displacement displacement caused by the sensing mass, that will be sensing by using electrical displacement transducer, electrical displacement transducer, or we call it as a potentiometer. So that's why we calling as a this instrument is also called as a potentiometric accelerometer. This is called, that's why we are calling as the potentiometric accelerometer. This electrical transducer also called as a potentiometer. So that's why this instrument is also called as a potentiometric accelerometer. So this is the construction of this accelerometer. So now we'll see the working of the seismic displacement sensing accelerometer. Right. So now we'll see the working of the this sensing displacement sensing is. So here for example, this is about our instrument. This is our instrument. Here we have a motor. The motor will be vibrating at the top portion of the motor or any engine. So we are placing this instrument, so that will be also vibrating. So if any accelerations of the vehicle are there, so that instrument also will be accelerating or vibrating due to the accelerating of the machine or vibrating of the machine. So this will be moving vertically. This instrument also will be accelerating or vibrating so linearly. So this instrument also will be accelerating or vibrating. So in this condition, so if the vibrations are more, so the displacement of the mass will be also more. So here the mass will be displacing. The basic principle in this instrument is mass will be displacing. The mass is also displacing. So the displacement of the mass is proportional to the acceleration or given acceleration of the motor or any engine. So here, if the vibrations are more, the displacement of the mass is also more. If the vibrations are more, the displacement of mass will be also more. So the displacement will be measuring. By using electrical transducer. The displaced mass will be sensing the electrical transducer, that will be finding that will be the displacement mass will be measuring or finding by using electrical transducer. So these electrical transducer displacement mass will be giving the vibrations of the particular machine or acceleration of the given vehicle. So in this way we are going to find the acceleration or vibrations of the machine. So here, so these sensing mass, so if the vibrations are more, the displacement of the mass also will be more. So if the vibrations are more, the displacement of the mass also will be more. So now the displacement will be connected to the one bridge. So here we are using one Wheatstone bridge. So the sensing mass, displacement mass will be connected to the one resistance. So here we have a resistance through the pointer. So here we have a resistor. We can use the Wheatstone bridge for indicating for finding the displacement. So here we are taking one resistance. So here this is about resistance. Here we are taking one resistance. So here the change in the resistance is changed with displacement. The resistance is changed with the displacement. So here we are using Wheatstone bridge for finding the displacement. So we are taking one resistance. So here the resistance will be changing with the displacement. With the displacement. So these will be connected to the